Alright, Math 1, let's take a look at this graphing 2. So we're going to be graphing some geometric style patterns. So from the table, pretty easy, we just take the points here, so -2, 1/4, and we graph it. So I go to -2 and up to 1/4, be about somewhere there-ish. Okay, then -1, 1/2, it's a little high. Not that high. There, pretty close. 0, 1, 1, 2, and then 2, 4. Okay, and remember that we've got this invisible line here, okay, normally there on the x-axis, called the asymptote, which it's going to get as close as it can to it, and then it's going to curve up. Okay, something like that. Alright, now, this one, -254, well, we only go up to 20, so I'm not going to bother with that one. So let's jump to the next one. -118 would be right about there. 0, 6, clear down there. 1, 2, right there, and then 2 2/3. Maybe a little bit higher than that. Not that high. That's good. So we know it's going clear up high, so we're going to come down, kind of sweeping like that, and then just ride right along that x-axis. Okay? And so that's all we got to do when we're dealing with graphing with the table. Okay, so let's take a look at 2 more, though. Alright, so -1, 3, 0, 6, here's our y-intercept, 1, 12, 2, 36, and 3, 108, so I know we'll start down here by the x-axis, curve up, and then it's just going to keep getting higher and higher at a very quick pace. Okay, and then number 4, -2, 1/25. 1/25, since this number is really big, it's going to be like almost 0, basically. -1 1/5, slightly higher. 0, 1, 1, 5, and 2, 25, so I know it's going up and getting up high like that. Okay, so using the table, pretty easy to see. What I shouldn't be seeing is that you shouldn't be making your lines look like that. Okay, remember, we gotta have that asymptote. So now, if we're using the recursive form to deal with it, okay, once again, we see the multiplication or division, and then we see the starting number, so our y-intercept and our growth. So a sub 0 is 1, so I'm going to start right there. And I'm timesing by 4. So the way to think about this is you can think about that y value of 1, okay, I'm going to times it by 4. The other way to think about it is kind of visually. Like you can see that this is kind of using up one rectangle. Well, now I need to quadruple that, which would put me up to 4. Okay, 4 rectangles kind of idea. And then I'm going to multiply that by 4, or make 4 more, so 1, 2, 3, and 4. So I get a point here, a point here. Okay? And then we know it hits that asymptote, so it's just going to curve up like that. Okay? Now, dividing by 2, that's the same as timesing by 1/2, but we start at 10. So 10's right here. Well, I just cut that in half. Okay? If I think about that distance, cutting it in half would put me at 5. Cutting that in half would put me at 2.5. Cutting that in half would put me like 1.25. Cutting that in half, and if I'm going to the left, I think opposite. What number up here would I need to have to cut it in half? Well, up to 20. Okay, so I can think of it kind of visually on that graph as well. Remembering that it's going to go out along that asymptote. Okay? So, same idea here. timesing by 4, starting at 1/4. So down there at about 1/4. Okay, then timesing 1/4 by 4. All that would be 1. Then timesing 1 by 4 would give me 4. Timesing 4 by 4 would give me 16. And so I know it's going to look like this. Okay, once again, this is 1/4 of this, which is 1/4 of this, which is 1/4 of that. Okay, now number 8, starting at 3. On my y-intercept, timesing by 1/3, that's the same as dividing by 3. So 3 divided by 3 would take me to 1. 1 divided by 3, 1/3, and so on. But if I go the opposite way, I do the opposite of dividing by 3, so I times by 3. So 3 times 3 would take me up to 9. 9 times 3 up to 27. So it would look like this. Okay, and that's how we can use a recursive formula to help us. Now, if we're dealing with just graphing from an explicit equation, okay? So, when we talked about that arithmetic, okay, that slope-intercept form, it was y equals mx plus b, okay? Or, we liked to do it more like this way. A sub n equals the starting number plus the growth times the variable n. Okay? Or, I think we usually use the start plus the growth times n. Well, we kind of have a similar one for the geometric. So for geometric, we would go a sub n, or y, equals our start times the growth to the n. Usually they write it y equals a times b to the x, where a is our y-intercept, our starting number, and b is our growth, not a slope, but our multiplier, what we're multiplying by. Okay, so if I look at number 9, we start at 2. So I go on my y-axis, I start at 2. Then as I go to the right one, like if I were making a table, 0, 2, as I go to the right one, I'm going to be timesing by 3 each time. So 2 times 3 would give me 6. So I'd have 1 6. 6 times 3, 18. So 2 18. And if I'm going backwards, so like -1, -2, I do the opposite. I divide by 3. Okay, or in other words, I cut this into thirds, and so it would be about 2/3, and then 1/3, and so on. Oops, that wasn't a very good line. But I know, because I'm not adding that k, if you remember back to that activity we did on Desmos, if I'm not adding that k, I'm going to have that invisible line that I'm never going to cross. So that really helps me when I'm trying to figure out how to multiply these. Okay? So if I look at 10, my starting number is 4. So I start at 4, and I'm doubling that. I'm timesing by 2. So 4 times 2 is going to give me 8, and I move over 1. 8 times 2, 16. 16 times 2, so on. Going backwards, 4 cut in half, or divided by 2, would be 2, then 1, then 1/2. Okay, and that's usually enough to remember I'm going to not go past the x-axis, so it's just going to curve up like that. Alright, so 11, same idea. 3 to start with, timesing it by 2, 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. Going backwards, 3 divided by 2 would be 1.5. Okay, but that's usually enough knowing that I've got this invisible asymptote, this line, that I'm going to start over here, and it's going to curve up. Okay, number 12, we can start with a fraction. 1/4 would be down there, then doubling it. Well, 1/4, doubling it would be like 1/4, 1 plus 1/4, which is 2/4, or 1/2. Okay, so let's try this again. So 1/4, 1/4, 1 Oh my goodness. These capacitive screens can be difficult. And then timesing that by 2 would be 1. Times that by 2 would be 2. Times that by 2 would be 4. Times that by 2 would be 8. And then 16. So I'm starting down here really low and then climbing up there. Alright, so now what we should notice here, the difference now is we've got fractions in here. Okay, if we think about the recursive form of an equation, it was alright to go divide by 3. Okay, this is the same equation. Well, one's explicit, one's recursive. Okay, it was alright to write the divide by 3 right there. But when we do the explicit, we can't write 2 divided by 3 to the x. So instead, we have to do the reciprocal, and so it's 1/3 to the x. So all that means is we're dividing by the denominator. So I start at 2, then I'm dividing by 3. So 2 divided by 3 would be about right here, so it's going to get lower. Okay. Now, when we had a number that wasn't a fraction here, okay, notice as the right, they go up like this. Okay, when we have a fraction, it's going the opposite way. So if I'm working backwards, if I'm looking to the left, I'm going to do the opposite of dividing by 3, which is timesing by 3. So this would jump up to 6, then 18. Okay, so we can see that it's coming down, and it's going to skirt across that x-axis. Well, not across, but right along with. So starting at 4, timesing by 1/2, or dividing by 2. So as I go to the right, I divide by 2 each time. And I know I'm going to hit this asymptote. But if I want to know how it's going to go to the left, okay, I just do the opposite. So what divided by 2 is 4? It'd be 8. What divided by 8 is 8? Or what divided by 2 is 8? It's 16. So that can give me kind of, and that was a horribly drawn graph. Huh. So it would look more like that. Alright? And that's all there is to it. Though sometimes it's a little more difficult. Okay, starting at 5, cutting that in half, you can think visually, boxes wise. That would be like 2.5. That would be like 1.25, and then lower. So we know this is going to be coming down here like that. And then going to the left, timesing by 2 would get us up to 10. And then to 20. So it comes down pretty sharply. Let's try that one again. So it was 10 here and 20. So we start low and then jump up pretty quick. Okay, now 1/3 times 1/3. So we start at about 1/3. Okay, as we go to the right, we're timesing by 1/3, so it's just going to get smaller and smaller. So it's going to be really tough to kind of see this. That it's basically getting smaller and smaller, so we want to go to the left. So 1/3 times 3 would be 1. Then it would be 3. Then 9. And then 27. So it'd come down here and really quickly hit along that asymptote. And that, guys, is basically graphing with those geometric patterns. Okay, notice that it is different, the arithmetic. Okay, on our table, we're adding or subtracting as we go down, input and output. We end up with straight lines, diagonal ones, vertical ones, horizontal ones. Okay, with geometric, on our table, this is adding or subtracting, but this side is multiplying or dividing, but we really think in terms of multiplication. So those graphs would look like this, or like this, or possibly even this way, or this way. Okay? And that's the difference. Not a straight line, curved lines. Straight lines. Arithmetic and geometric. And there we go.